Okay, get yourself prepared with the lesson. Open the camera, let me know you're here. And I would like to have a interaction. So could you please try hard open the camera? I would like to have a more seeming like face to face. 馮家謙可以會 wear mask quarantine
我病病地
quarantine at home you better not okay you better not affect your family members.
我有少少病病地啦。
Have you done tests?
Yes. No, I don't know the result is what.
So unlucky.
I don't know. Until now I don't know. I'm positive or negative. The quick test show me is positive.
Sorry, you've done preliminary test on the kid.
Yeah.
It's showing positive.
I don't know whether it's positive or negative because the T have a slightly red line in there, slightly, but not. Yeah, right. This strict red. I'm slightly red.
So actually, for the testing, I have not taken a look at the kit. I don't know the process. Anyone who can tell me the process?
其實同你去撩鼻一樣，都係要捅支棉花棒入去撩5個圈之後，即係兩個鼻撩5個圈，之後再插落個 solution 度，即係又好似 titration 咁樣要揈嚟揈去，之後再滴3滴嘢落去嗰個窿度。
What will happen with the hole? I know there is a hole. I drop some sample, so the water level will rise. Is it? The water level will rise, and which is those
just filter paper. Filter paper.
It seems like filter paper.
Yes.
And while you see the water level climbs up, is it?
Yeah.
Oh, I know. I can guess the working principle. Do you know what is the working principle of this? 有冇人知啊? Now, first of all, it's about the virus having get reacted with certain chemical, okay, to form some color species, to form some species, right? While that is the principle, but indeed, while you get mix of it, I don't know what's the real principle. I think the filter paper with the two line, okay, with the two line will have some hidden chemical. I spray on it. While whenever you put the sample into the with the solution, that will get mixed with form another chemical. Okay, while another chemical that will climb up to the filter paper. Okay, we call that chromatography. 色層分析法啦. So you climb up, so it will meet the hidden chemical on the line. Once you meet while there is the presence of certain chemicals found inside the virus, and they will react together to form something red. Okay, if you find that the red line is faint, which means that you may have got infected, but the level is a trace amount, but not high level. The more darker the color, which means that the more vulnerable, the more probable that you are got infected. So, of course, that type of conclusion is based on one assumption. Okay, it's based on one assumption. Assumption is that your test is your sampling. Your sampling is just got one sample only, right? So those while the accuracy is 100%. Of course, these tools they are not. So from Gahim, I urge you to really go to the COVID test center, the mobile.
I'm waiting for this result.
You have done that?
Yes.
The one which is run by SHP?
Yes, 60. Yes.
Okay, and wait. What you can do is wait.
Yeah.
And during the time, besides you do the testing, you better not go out so often. Okay. Please do not hang out with your friends during this period. So what we welcome all of you. Could you please open the camera? Let me know you're here. And I would like now more.
千Sir 聽唔到，
係咪未開咪？
I press it wrongly. Sorry. Intentionally, I want to open the. I want to have a share the substance, but I accidentally pressed the mute button. Sorry about that. It seems there is one dancing. Anyone will check for me? We've got 22 here. We have got 23. Is that?黃俊熙嘅放兩張。梁家傑 ，Hello， 佢燒梁家傑，梁家傑。All of you. Now, shall we start the lesson. Now, as said before, okay, please turn on the camera. Let me know you're here. All right, so you may get this chapter, unit 33. Okay, just turn on the camera. Let me know you are here. Thank you.唔使怕醜啊，開啦，要開一齊開啦，我都開咗啦。Now, unit 33. Right. 陳許婷、長學家、何慧琳、林俊軒、林成漢、李貝恒、鄧俊熙、鄧浩俊、黃俊熙、黃奕朗、張思維、馮家謙、李晴、梁家傑、李健樂、馬家樂、吳漢一、魏俊滔、黃成軒。Now just turn on the camera. Yeah, thank you. Hổ. 死啦！又咁啱得咁巧啊，真係。While I talk to 馮家謙 and here comes a new topic on important organic substance and here comes this. 咁巧嘅。Now this one, aspirin. In Hong Kong, we seldom use aspirin. We will use paracetamol. You know the difference? You know the difference? Paracetamol and Panadol. Now, in Hong Kong, we seldom use aspirin, we use Panadol. Well, Panadol is just a brand name. The chemical name, we call it paracetamol. Okay, anyone who can search on the web, what is the structure of paracetamol? Paracetamol. And this one. Do you know the difference? Now, spend some time, you search on the web and tell me the difference between the action of paracetamol and aspirin onto your body. Aspirin. You know it? No CH3 group. What else? The same? The structure, they are more or less the same. Now, not really. If you search on the web, you take a look on the aspirin versus paracetamol, you will see that, right? Panadol. And you may find the structure being different. First of all, the structure. Besides having this chemical, all those we collectively we call the anti-inflammatory drug. Okay, 消炎藥. So it will cause you, it will reduce your inflammation by reducing the amount of hormone that cause inflammation. Indeed, inflammation is a normal process. Okay, it's a normal process of a human in response to something, for example, infection or deal with usually infection, right? So they are making a war. They try to do some speedy recovery. Okay, so for those areas will be swollen. Okay, it's usually like that. So on the market, we have got paracetamol, aspirin, and ibuprofen very often. Can you see that? We would call that all those we call that non-steroidal steroidal anti-inflammatory drug. Okay, you know the steroidal drug you usually need the prescription prescription of from the doctor. Okay, which means that without the signing of the doctor allow you to buy the drug, you cannot buy the drug. Okay, while the pharmacy store will not allow you to buy the drug unless there is a letter from the doctor. Okay, we call it prescribed drug or non-prescribed drug. You know it. While that three, we call that over-the-counter drug. Over-the-counter, which means that you can buy it. Have you ever heard of that? So usually we use these three, but aspirin will not be so widely used because of more side effect than the others. Okay, for example, it causes some uncomfortable feeling on the stomach, some bleeding of the stomach. That will be usually seen when you talk about aspirin. Okay, but of course somebody may have heard of you know that in the preliminary stage, while we have got a vaccination, people were once have got a message of taking some aspirin beforehand in order to prevent some blood clotting. Have you ever heard of that? So aspirin, it is also help to reduce the risk of stroke. Indeed, that is the truth. So aspirin can also be used besides as an anti-inflammatory drug for those people who got heart disease because of the possible blood clotting inside. They may be asked to take some aspirin. Don't you know that? 有冇聽過？冇啊？ No. No. So I just want to tell you something more about the drug and your daily life. Remember, you talk about organic chemistry, you usually relate it to our daily life. Okay, among the three, we will will you have a chance of having a quiz or exam to show you the structure of ibuprofen and paracetamol? There is a chance. So don't worry. As long as you take a look on the shape, you know the presence of certain functional group, and that is okay. And you may predict the chemical properties. Okay, now you take a look as a warm up of that three chemicals. Okay, what is the functional group found in those chemicals? Lý trình. Phải tiêu không? Paracetamol. Yeah. Now take a look on this, on the on the left-hand side, OH. It is, what is that?
hydroxy。
Yes, it's hydroxy group. What else?
有個 ketone 個 carbonyl group。
Ketone. Is it ketone? It's not
唔係喎
ketone.
A 埋嚟嘅 A 埋。
You merge with the NH group altogether. It's amine. It's not it's substituted amine. Okay. How about this? Magala. We call that it's aspirin. We've got two functional group here. What are those two? Magala.
Hello，
你答我 hello 做乜鬼嘅？What are the functional groups inside? Anyone who can help?
Carboxyl group 同埋 ester
Carboxyl group on top, below
ester
is ester. How about this?
carboxyl group 呢個
Only carboxyl group. For the others, they are just methyl. It's not a functional group. Okay, so all those they will call it as a drug. So you may easily search on the web to get to know some so-called common knowledge. Okay, so indeed we look for the functional group for this aspirin. The aspirin is just a brand name. Can you see that? It's just a brand name. So it's a trademark. And the true chemical, we call it acetyl salicylic acid. Acetyl means here, salicylic acid means here. So salicylic acid, it is a derivative from the chemical in the willow bark. In the past, it's a traditional wisdom with the Western country. People at that time will chew the willow bark if they got fever, if they got some painful feeling. After chewing that, will be the painful feeling will be relieved. But the willow bark is quite nasty. It's because some people who take in willow bark, you have got bleeding in your stomach. So that's why I do some slight modification of the drug, such that on one hand it can cure you, but at the same time it will cause less side effect to the drug. So very often we deal with all those anti-inflammatory agents. They will go with some anti-acid tablet. Do you know that? So that anti-acid tablet is just a graphic juice or graphic acid inhibitor. So it is used to further protect your stomach. Okay, so this is what you know about the drug, carboxyl group, ester. They have that two functional group. So salicylic acid is the chemical that we find it naturally in the willow bark. So suppose you have got this. My question comes, identify a reagent that we use to under appropriate conditions to convert aspirin into soluble aspirin. Okay, what do you think, Lim Seng-Han? What is the synthetic steps?
Sodium hydroxide.
Sodium
hydroxide.
Hydroxide. On which step? All steps. Which means the second step, is it? Aspirin to a soluble aspirin, the second step. Sodium hydroxide, this part. Now, besides sodium hydroxide, you can also add milder chemicals. Okay. What else? You may think of sodium carbonate or sodium hydrogen carbonate. Also, yes, you can also convert to sodium soluble aspirin. Suggest why aspirin has a low solubility in water. Very difficult to tell, right? Tell me.
Because it can form very little hydrogen bonds with water.
Little. Indeed, we have got functional group. We have we can form hydrogen bond with water. This one, the hydroxy group, right? So even though the hydroxy group, the carboxyl group can form hydrogen bond with water, so it is said to be soluble, right? Isn't it? However, how about this? We've got the large group of other parts in which it does not dissolve in water, especially this, okay? Especially this, the benzene ring. It is not what? It's not water soluble. Why? It is, how we call that?
Aliphatic 嗰啲
Aliphatic. Aliphatic. It's not aliphatic. This one.
Non-polar，你放唔到
It's
hydrogen bond。
non-polar. Yep. It's non-polar, which means that it is hydrophobic. Hydrophobic, which water hating. Doesn't like water. So that is the interaction of water only help between water molecules by what? Just van der Waals force, which is a weaker attraction force. Okay, so we will call all together aspirin. They have a low solubility in water. So remember, it's not just taking a look on the chemical. We have got the certain functional group which form hydrogen bond with water. We can directly tell the compound being water soluble. But also you are going to take a look on the whole other structure, whole other parts of the molecule. If the hydrophobic part is quite large, you cannot say that it is water soluble. Now this one is the case. Now, while the question comes, explain why the soluble aspirin is more soluble than water in aspirin. Why? With a slight modification like this, why would we become more water soluble? Now, again, the focus is on this. Yes, first of all, it is ionic. It's ionic. Okay, so they will have a strong interaction between water and the ions. So what is that interaction called?
ion dipole.
Ion dipole attraction force. Ion dipole attraction. Okay, so which is much stronger when you compare with hydrogen bond. Now it's a matter of comparison because of the term more soluble. So you are going to make stronger. What to compare with the hydrogen bond? Remember, because you are going to make a comparison between aspirin and soluble aspirin. So you have to tell the aspirin what functional group they will have and what is the interaction with water. So you know it's hydrogen bond. When compared with van der Waals force is strong, but you have got soluble aspirin having COO minus Na plus. Now sodium carboxylate group, which is in which is ionic part, it forms ion dipole attraction with water. While this attraction is stronger than hydrogen bond, so we call that a strong higher solubility in water. If you talk about soluble aspirin, you got it?
錢 Sir，
Yes.
我想問，即係佢，因為佢都係 ionic 嚟噶嘛，即係 ionic substance 啊嘛，佢係咪都係要 follow 翻，即係譬如話係 molten state 同埋 AQ state， 即係 AQ solution 嗰啲先至係叫做 soluble 成嗰啲啊，定係佢係唔關事嘅啫？
咩 AQ 唔係 electrical conductivity 咩？
Now, you are talking about two concepts. First of all, if you want to talk about a molecule, a substance being water soluble, okay, being water soluble in organic chemistry, we usually deal with two things. One, you take a look on the whole structure, Check the water solubility of a substance. So first of all, I try to make the case simpler. The substance, we call that, we identify as organic compound. So what will happen? You are going to think of two parts. We call that the hydrophilic part, anything which is water loving, hydrophilic. Water loving. For example, you have presence of functional group, polar functional group, especially COOH, OH, all those they will have ability to form hydrogen bond with water. So, okay, how about coral? Coral is also functional group, but it will not form the hydrogen bond, which forms hydrogen bond with water. So this molecule, which is water soluble, but if you are going to talk about the hydrophobic part, which is as small as possible, okay? While hydrophilic part, it is as many as possible. The more the hydrophobic parts, the more soluble we can talk about the organic substances is. Okay, the small hydrophobic part, what is mean by that? For example, the length of carbon chain, presence of benzene ring, etc. So this is our general principle to check the water solubility of a substance. Okay, it is what we call it as an interaction between water and the molecule. Now we focus on the interaction between water and molecule. So what is the interaction? You can think of two ways. One, if you talk about this, okay, it is hydrogen bond. Okay, what this with water is just weak van der Waals force. So it is just for the molecule, in case we have got both parts together, it seems like a competition between the two, right? Which one will dominate over the other? And it will tell you finally which is it water soluble or not. The larger the molecule, even though you have got quite a lot hydrophilic part, it doesn't mean it is water soluble, because the hydrophobic part will unfavor okay, the formation of hydrogen bond between of the functional group with water. No need to mention it itself doesn't form any hydrogen bond with water. Okay, so this is point 1. Point 2, on top of this, there may be some substances in which it is ionic. Now, for example, this, if the whole molecule with certain ionic part, just like COO minus Na plus, this part it is more water soluble than what we have just mentioned, is because that part it will cause a stronger interaction between water and iron. That more intermolecular force, but that force we call it ion dipole attraction. It's not intermolecular force. It is a force between the ion and the molecule, while the molecule is highly polar. Do you understand? 3, what you just mentioned, it is something about ionization, isn't it? Now that is another phenomenon. Ionization is a process in which this molecule, for example, aspirin, we've got COH, right? Once it dissolves in water, that molecule will have the interaction of water such that the H from the COH will be ionized. Okay, will be released. It will be released as hydrogen ion. So the whole molecules, once after dissolution with water, it will have an interaction with water to form ions. So it is another thing. Okay, do you understand? Hello， 頭先邊個問㗎 ？OK， 明啊？咁呢度係講幾樣嘢㗎，幾個層次嘅問題嚟㗎。咁你咩 molten state、aqueous state 嗰啲咩嚟嘅咧？就係講緊你係咪想講佢有冇 ion 啊、導電性嗰啲係嘛？咁如果你講緊係導唔導到電咧，你就睇下佢呢啲 molecules 用咗落水之後，會唔會 ionize 晒，或者 ionize 嘅地方多唔多啦，而構成佢導唔導電啦。通常我哋講緊啲藥咧冇咁 simple 嘅嗰粒 molecule， 通常比較複雜啲。咁所以咧佢哋未好多都唔係好溶喺水。咁但係咧去到你個身體入邊，即係 in the digestive system, some of them is ionic, some of them is a little bit basic, that there may be some interaction with it to form something more water soluble, which will help you absorb this material inside your bloodstream in order to make the medical effect taking into action.
咁我想問咧，如果我即係佢係譬如 aspirin 咁樣，即係唔係 soluble 嗰啲 aspirin 咧，咁係直接寫 insoluble 定係寫 slightly soluble 定係點樣
？It depends on the questions. Now, very tricky in the organic chemistry experiment. We usually talk about it's not just soluble or insoluble or not. We talk about soluble, highly soluble, slightly soluble. You talk about extent. So be aware of it. If you talk about whether or not the interaction, the organic substance with water, you are going to describe it as a highly water soluble or slightly water soluble in consideration of both parts, the hydrophilic part and the hydrophobic part. Okay, is that clear? So you are going to consider both. You still need to take it. You still need to take that two into consideration. Okay, questions? 兩個都要講啊，所以你話佢話你唔可以就咁齋講溶唔溶嘅，我要講咩？佢幾溶法，我要講嘅。Okay, questions? Now we come to this is the first part for aspirin. Now take a look on those exercises related to aspirin and let you know how you get approach to the problem. Some of them you think that isn't it? What way will the question be asked? Right, aspirin. This is the one. I really tell you the truth, right? Ibuprofen also appear in the past paper. 我唔係吹水㗎，真㗎。Okay, so this is question 13. You take a look. Aspirin's painkiller structure is shown below. Now we'll get close to this. State a medical application of aspirin over other than painkilling. 黐線 How we get the answer?
Alleviate heart disease 咁樣。
VVD heart disease. Yeah. What else?
Reduce fever.
Yes.
Inflammation and fever.
Okay, reduce fever. Yes, that's right. You can think it like this way. Reduce fever is the common way to the public. You talk about the use of aspirin. Okay. Okay, so explain why a suspension of aspirin water can become clear when the sodium hydrocarbonate powder is added. 係咪好無聊咧？真係問嘅喎。Why? So when the aspirin will react with sodium hydrogen carbonate, what will we form? What will we form? Once again. Yes. Which part will react?
S group 有 alkaline process.
No, the carboxyl group will react.
Carboxyl group. So the structure, if you are unfortunately asked for the structure, you are going to ask for it to draw a structure like this. So don't worry about how lengthy or how large the molecules is. You just focus on the reactive, the active side, okay, the reactive part. And together with what? You are going to think of CO2 and H2O, right? Like this. So in this case, you form a sodium salt. So you are going to tell the COOH group of the aspirin, the carboxyl group, reacts with the hydrogen carbonate ions in water to give what? To give a sodium carboxylate to form a salt, carboxylic salt, which is water soluble. Of course, if you want to mention more about how come it is water soluble, you can mention something about the ion dipole attraction between water and the iron. Okay, you can also mention this. So according to the past paper, we just talk about, we can, they will accept the answer. You talk about sodium carboxylate, and it is water soluble, and it's okay. However, while you don't know whether or not they will increase the level of difficulty in the questions, so you are going to mention more. C1, heat aspirin with excess dilute aqueous acid under reflux to give to organic product. Or this one, this chemical undergo acid under reflux to give organic product. It is the acid hydrolysis, right? After acid hydrolysis, we got two compounds. What are the two? Ammonia.
係咪出一個 carboxylic acid？
Carboxylic acid. What's the name of the carboxylic acid? Now, this acid hydrolysis, right? So, which functional group will be broken? Will be hydrolyzed?
Ester.
Is here, right? Ester. So you split it into half. Okay. So which left hand side or right hand side? Which one is the acid? Which one? Which one seems like more like an acid?
右邊嗰個。
Yes.
No,
So
double bond.
you should write OH here, and that the problem is solved, right? The OH and then put in H. So the answer is this. So how you get approach to the problem? The two organic chemicals is, now I would like to show you how to get approach to the problem. Now here, you try to remove this one. Can you get my point? You try to remove this one. I add H here, and I add OH, and that is the answer. Can you manage, huh? Do you understand what I just said? The one on the right hand side, on the right hand side is what acid? How many carbon?
2.
2. We call that?
Ethanoic acid.
Yes, it's ethanoic acid, but it's just a skeletal formula. How about the one on the left hand side? So how you call it? Okay, salicylic acid. So do you see it? It's salicylic acid. So that is the original chemicals you are looking for. Questions? Okay. Okay, salicylic acid. Salicylic acid. SALICYLIC. So this is what you know about this. Explain why the conversion of aspirin to these two organic chemicals can hardly reach 100%, even though the mixture of aspirin and dilute acid is hidden in the reflux for a long time. Why not? Long. What we usually express about the acid hydrolysis, we use a double arrow, right? So what is the hidden message about this? It is a type of, we need to mention this term, reversible reaction. Is a reversible reaction. So in this reversible reaction, both the reactants and products, they would attain equilibrium. A very attains equilibrium position, and reactants and products, they will coexist. So you will know it, okay? So you will know this in the last chapter and second last chapter in your syllabus, okay? So both the reactant and product will attain equilibrium. So, and when both these two they will coexist. OK， 咁所以咧，我哋有陣時咧要做題目咧，會見到一條寫嗰個相戰序之後咧 ，so we have got a very strange sign. We've got a K, right? The K is just a quotient. Okay, it's a quotient to tell you the relative amount of the chemicals between the reactant and product in this equilibrium system. All right, any questions so far? 魏俊滔 ibuprofen is a painkiller. Structure is shown below. There is this enantiomerism. Just to remember what's that? Draw the three-dimensional structure for the pair of enantiomers. First of all, enantiomers, we have got a chiral carbon, right? Is it a chiral carbon? Is it where we will find the chiral carbon? Where? 邊度？ Where is the chiral carbon? Junto, are you here? Hello， 魏俊滔，係唔使嗨我啦，唔使答問題得㗎啦。Chiral carbon where? Deng Haojun, where is the chiral carbon?
COOH 隔離嗰個，即係病線右邊。
Yes，
係咪？應該係。
應該係。So we have got three bonds.
係呢個。
Yes, what are the fourth bond? What is that? The hidden bond. Yes, it's hydrogen. So you start from this and you draw the 3D structure. How would you get approach to this? So usually we would have this framework. Now don't worry, every time while you draw this, you have to do this framework. And what you need to do is to draw the following: CH3, okay, and then what? H, COOH. How about the bulk is in here? Okay, so you can directly draw this. Okay, so you may find this and this at the opposite side, right? So you write here, and then this, and this is the structure we are looking for. Remember, only you focus on the chiral carbon as a center, and you use this carbon, you enlarge it to form a tetrahedral. Only this part only. Okay, no need to do the other part. So the remaining, you are going to draw the mirror image. So this one's H. We got COOH. Remember, the C should be connected to C. So I intentionally draw the one as HOOC, right? Indeed, we focus on the carbon connectivity. Now this one is CH3, again carbon to carbon. And finally this, we have got a benzene with this, like this. So it is the way to draw the 3D structure. Remember, only the chiral carbon here, we are going to enlarge. Okay, enlarge it and show the dead carbon. And you use this as a center to draw the tetrahedral shape. What's next? After you draw the tetrahedral shape well, you just put them to them back the groups of atoms, and it's solved. Questions? Now you, even though the structure is quite large, you can still use the same tricks to solve the problem. Questions? Any questions? Okay. 到未？得啦，即係話 if you know how to draw, we come to the other chemical. This time we will not talk about soap and detergent because it's a very large topic. I will leave it in the next lesson. Well, today we talk about condensation polymer. Please take a look on this page, 33.7, page 203. All those undergo a category, condensation polymer. So they we have got the two examples. One is polyester, the other one is polyamide. Okay, polyester and polyamide. So we will come to this. Polyester, they are polymers in which the monomers, they are linked together by ester linkage. While what is meant by polyamide, use the same concept. The monomer units, they are linked together by amide. So the formation of ester, they will consider a series of condensation reactions. So in between the steps, there are some chemical lost. So usually it's water. So that polymer to be formed, we call that condensation polymer. So this part, have you ever heard of this term before? Very similar to addition polymer, isn't it? So it seems like we have got some monomers, they are linked together, but condensation polymer would require the reaction involving condensation, while the addition polymer will involve the reaction of addition. And the elimination product for condensation to be found, while addition there will be no atom lost. In order to have such, the monomer should be at least two suitable functional groups to have such a reaction. So it's time to take a look on this. You are going to, let me see. I would like to make a comparison here. here. I would like to make a comparison here. So you're going to make a comparison table to talk about addition polymer and condensation polymer. Okay. So first of all, it's about the monomers. The monomers, both they would, you talk about polymer, right? So the monomers, there is a monomer containing what? CC double bond. While the condensation polymer, they will have contains two
carboxylic acid.
Yes, carboxylic acid. Two. Eh? Oh, why can't I? Okay. Contains two functional group with the following combination: one COOH and OH. They will form ester. How about amine? How about amine? We've got COOH and what? NH2 to form amine. So recall your memory, the ester here, it is the functional group COO minus, COO with single bond, while amine is CO and then NH continue. Or we will not end it as C double bond NH2. It's just in between. So we will not have C double bond ONH2. Instead, we've got C double bond ONH with the two hands just continue. Okay, so for this addition polymer, finally here comes the basic unit like this. Okay, so here comes the nature of reaction. The nature of reaction is addition. This one, of course, I carry is a condensation. So it will tell you no atoms lost during the process. Well, for this one, some water molecules. It's just a small molecules. They are eliminated. Now, why would we say that? Why Mr. Chin will not say it must be water? It depends on the chemicals combination. Now, you stick back to the chemical combination above, the water, of course, will be eliminated. But I change the COOH as acid chloride, for example. The eliminated product will be HCl. So it is very complicated. So I don't mention about this too much about. And was next the repeating unit. The repeating unit. The basic structure of repeating unit. So for the addition reaction, the framework will be this. But for the condensation polymer, the basic unit will be this. Okay, or while you see first change, right? The triangle, the rectangle, it is just a carbon carbon chain of various length. or if you want to talk about polyamide, it will be something like this. Of course, you may think of other combination, right? In other triangle, I don't know. They are not necessarily the same, right? It depends on different combination. But if you want to talk about the repeating unit, so you will get to know how to make a bracket here, okay? In order to make it as a repeating unit. So you will know it. Now, for example, this one is a repeating unit, while the one on the right-hand side, what is the repeating unit? 點畫啊？ What is the repeating unit? Now, so you may further draw this. I'll give you some hints, right? You may further draw this. Can you identify the repeating unit now? It may be this, right? And also it may be this, right? Oh, somebody may argue, can I shift a little bit one way like this? Can I still call it as a repeating unit? Or you shift it one more to the triangle, right? Right after the triangle, I start to mark it as a repeating unit. Can we do so? You can. So it depends on the structure of a monomer. So if you want to talk about the condensation polymer, the two functional group, the positions should be at both ends. Okay. So if you finally, you will want to talk about the chemical reactivity. Now, if you want to talk about addition polymer, is said to be more chemically inert. While you talk about this condensation polymer, it can be hydrolyzed by acid or alkaline. Now, because of the linkage, you may find here, right? Because you have got a ester linkage and amine, while the two functional group can be cleaved. Is that clear? Questions? Any questions so far? Any questions so far? If no more questions, I would like to continue right on the two examples on the book. 有咩問呢度？ O 唔 OK 先？我 double check 我睇下我冇啲相喺度先。Yes, that's right. I've got this. So I'd like to share it onto your capture the screen. Have you all got it in your Google Classroom? Please check. Have you got that? So we come to, for those who have received the work through the Google Classroom, please type in the chat box, let me know. Now, so we come to the two examples. One is PET. PET you usually found in what? In water bottle. For example, in water bottle, in as a fabric. So you may find as a polyester. While PET it is found in water bottle. I've got another one with polyfabrics. We call that Decron. Now you know in the other case. Now polyethylene, it is most commonly found polyester. We have got difunctional group, dicarboxylase and a diol. So you may find the monomer having two types. Can you see that? We've got two monomer. We've got two monomer. But for the addition polymer, it just contains one type of monomer. Do you mean that condensation polymer must contain two? No. You can also think of one chemical in which we have got that's this one, COH, and this one is
你唔記得 share 係嘛？我係好似睇唔到。
Let me see. Can you see that now? Yes. Now we have got this, right? It is just one type of monomer. But if you want to talk about this, you have got two types of monomer to make the condensation polymer. You may have this later in a later case, okay? We'll get this in a later case. And the name we call it is terephthalic acid and ethylene glycol. It's a common name. If you talk about the IUPAC name, we call it benzene 1,4-dicarboxylic and ethane 1,2-diol. Okay, so we would come to the condensation process. So the condensation process seems like this. Suppose you mark it as A, you come as B, you mark it as A, you mark it as B. Finally, here comes the pattern A, B, A, B. While the linkage, all those they are made it as ester. Can you see that? So we have got the linkage here. So what will happen to this group? This group will continue. This group will continue to have a reaction. Okay. So the repeating unit, we call it this. The ester linkage. So remember, after O, here comes the C. And on here. So we call that a type of ester linkage. How about this? After the C, what will become? We will call it O and then CH2. CH2, we've got O, blah, blah, blah. Right? So this is how we locate the repeating unit. Okay, or you write like this, the whole equation, N monomer to form repeating unit with a bracket N, 2N-1 H2O, which is polyester. Okay, while you want to talk about PET, we will use it as a water bottle. Besides, it's a type of clothing, tailoring. Okay, so it is it's a type of brand name, which talk about the fabric of making some clothes. Okay, so crease resistance, which means you need not iron. You need not iron the shirts, okay, the wrinkle-free shirts. 防皺嗰啲啊. So you may find this easily found in your shirts, the long sleeve shirts, while you're having the school uniform. But if you buy a long sleeve shirt which is made of cotton, sorry, you need to iron. You need to iron it because it is not crease resistance, or will not. We'll call it as wrinkle free. It's not wrinkle free. Okay, and mainly it is on PET bottle, mainly on bottle, soft drink bottles, and also fabrics. Now, one thing I'd like to mention is on here. The exit is under acidic medium, alkaline medium, they will easily hydrolyze. Okay, so be aware of washing the clothes. If it's highly acidic, highly alkaline medium, the shirts will got a hole here. Okay, is that clear? So we are. What's the time? It's now 11:37. So we just stop it here. We talk about PET only, and here comes another way for you to talk about polyamide in the next lesson. All right. So go home and please try out this class practice 33.4, and we will continue in the next lesson. Now, before you leave, let me know your understanding and any difficult part so far. Now we talk about what? We talk about aspirin, the structure of aspirin. We talk about some of the questions involving aspirin, and you also mentioned something about condensation polymer with reference to the comparison with addition polymer. Now, last but not least, have you checked the Google Classroom? If I post the capture photo there?
Yes.
You found it? Yeah. So you may take reference to it.
睇到。
Yeah, 有啊. So remember, I've got some comparison of both, but the monomer, the type of monomer is different. One more point I did not write is on the monomer. Okay, on the left hand side, addition polymer just one type, or the condensation polymer it usually contains two types. All of you please mark it down into the diagram as well. Okay, questions? Now, if not, I will see you guys in the next lesson. Bye bye. I mark the picture. Whether or not I got版係咯冇。